My name is Brian Lewandowski. I'll be the presenter today. I am the Civil Product Manager at CTC. I mostly spend my days working with developers, putting together this software, kind of designing out the interfaces, and then of course doing webcasts like this and reaching out to you folks to make sure we provide the best software possible. So let's start by talking about earthwork calculations in Civil 3D today. What does this look like? Well, there's a lot of different methods people incorporate, and I just want to touch on a few of these points because these are the main things we're trying to address with CTC Earthwork Processor. I think we'd all agree it can be fairly time consuming and not to mention error prone with the current tools we have in native Civil 3D. When we're dealing with variable depths across the site, something like this will be the example project we work from today, where we've got light duty and heavy duty pavements, sidewalk areas. That becomes a real challenge in sites like this, be it in residential areas, commercial sites like this, certainly a challenge. Updating things, updating those earthwork numbers after you make changes to your proposed surfaces. Maybe you're shifting the outline of where different subgrade depths change. Updating those earthwork volumes is often a big pain. And labeling and tabling of this stuff, right? It's not a matter of just getting the numbers, but putting them into Excel or into an AutoCAD table. A lot of that stuff becomes manual as well. Really wasting a ton of time when we just simply want to extract data from our designs to continue on and make quick decisions with our project. So what is Earthwork Processor? Well, the name kind of spells it out, but it's a tool that will calculate complex site earthworks by subgrade region. And so again, here's my example where I've got different pavement depths, different parts of my site that will have different subgrade depths to them. How do we calculate earthworks based on a simple finish grade surface that represents only the top of all of that? Earthwork Processor handles variable subgrade depths. This is one of the most important parts, right, to be able to handle this and to do it effectively. Earthwork Processor handles topsoil stripping. Typically, we're dealing with some level of stripping on the site before we come in to grade the site. And then, of course, Earthwork Processor needs to handle labeling and tabling, Excel exporting, and we also allow it to do hatching if you wanted to hatch your different regions across your site. So all kinds of exporting annotation options are available as well. And finally, a lot of times the way you kind of define this, be it cut factors, what kind of defines your earthwork definition, your earthwork set, can be repeated from one project to the next. So we can, much like many of the other tools in the CIM Project Suite, you can save out templates that can be reused in other drawings or in other projects. So what does the process look like, or the workflow in Earthwork Processor? I've got a screenshot here. We'll jump into Civil 3D and I'll show you in action in a minute, but let me give you a little overview of how this works. You start by defining an earthwork set. Now, an earthwork set could be your entire site or just a portion of your site, okay? You assign proposed and existing surfaces, and then you manually select or use a filter method to specify subgrade regions. And subgrade regions could be polylines, they could be feature lines, and they could be figures as well. So right here, I've got a filter that will pull in a variety of geometry here that represents different areas across my site. We can then set the stripping depth for different regions. And then next, Earthwork Processor will create subgrade and stripping surfaces for us and calculate those volumes. Here's a profile of what we'll be after. This dashed blue line represents my subgrade surface with variable depths. And then the dashed yellow line represents a stripping surface based on my inputs right here. Okay, we'll talk more in detail about those inputs, how they work. But the important thing to know is we simply provide two surfaces and then the regions where those different subgrades vary. We can rerun that earthwork set at any time to respond to a change to, say, the finished grade surface. We can also label, table, or hatch, or export any of these results. So apologize for a little of the background noise. I'm running this from home today and a number of things going on. So tried to find the quietest place in the house, but nevertheless. So let's jump into Civil 3D. Let's work through this a little bit. So what I've got here is a commercial site with a parking lot, turf area, some sidewalk area, okay? I've got a plan view, I've got an isometric or a model view over here, and I've got a profile view right here, and that is based on this alignment right here. That is just an alignment running north and south across my site. So the bottom of this represents the left side over here, so the alignment runs from south to north. Now the other thing I've got a finished grade surface, and I've got an existing surface. And then I have some polylines drawn that represent the different, let me pick that, represent the different areas across my site for different subgrade depths. This is a heavy duty pavement area. The magenta is a light or a medium duty pavement area. The yellow here is a sidewalk pedestrian area, and the green is just a topsoil area. Now what your site looks like obviously will vary quite a bit. Somebody might be thinking, well, what about curb islands, Brian? Can I have the depth vary there? Absolutely. If that geometry is created, Earthwork Processor will consume that and will generate a subgrade surface based on whatever regions you define, okay? And then one other thing here is I've got some elevations assigned to these polylines that simply represent the depth of the subgrade at that location. I'm using a few polylines here, but we can use feature lines and survey figures as well. Now, some of you might be thinking, you know, this sounds like this is a familiar workflow. Set polylines to the subgrade depth. And you're right. What we've done is we've taken what is a very manual, tedious process, but nevertheless works in Civil 3D to generate subgrade surfaces. And we've automated that in Earthwork Processor. And then, of course, the important part is that we can export those results, tabulate those results, and label those results. So the process we're going to run with Earthwork Processor is nothing proprietary. We're not going to create objects that wouldn't normally exist in Civil 3D in the first place. We're going to run processes that you could do on your own otherwise, but either one, they're entirely too confusing to do, take too much time, or maybe you're just not even aware of how you do it. What is straightforward is to think about my proposed surface, my existing, and simply my subgrade regions. From there, Earthwork Processor will take care of the rest. So let's open up Earthwork Processor. And it's a quite simple interface. I create rows in here that represent earthwork set. So I'm going to hit plus over here to create a new earthwork set. And we'll call this, how about EW1, earthwork 1. I set my proposed surface, I set my existing surface. And then from here, I need to define the different areas in my site. Okay, and we've tried to make this as simple as possible. You simply have a polyline, you simply have a feature line that represents that area. We can do two different things. I can pick these objects right out here on the screen, like this. And in that case, it shows up right in here. I get now what we're calling a subgrade region within my earthwork set. Or if I've got a variety of them and perhaps I've got some layering and things like that that allow me to automatically pull that in, I can set this to filter mode and then instead filter and grab all those objects based on layer description, the name of the object, the style, or the site. So I'm going to go out and grab that same magenta object, that polyline, and it's going to read, I picked the wrong object there. Let's grab this cyan one over here. Okay, so this found the layer name Earthwork Pavement Heavy Duty. Okay, and I've got all of my region objects on layers with the letters that start with ERWK. So I'm going to set that. Okay, I hit OK. Now that's going to pull in every object that's on a layer that starts with ERWK. Now I might look at this and go, right, it got it all. But maybe there's one thing, like I've got a boundary on the outside of all this stuff. I don't want that. Okay, so we've got exclusion filtering in here too. So I could say, well, exclude anything that has BNDY in it or ends with BNDY, and I hit OK, and now it strips that out. Okay, basic query and filtering logic. We have this same kind of stuff across Autograder, Label Genie, and Data Wizard, some of the other big robust tools in the CIM Project Suite. And we're trying to bring consistency across these tools and how you work with your drawings. So you'll find this very familiar if you're used to Autograder and Label Genie. All right, let's move on. We've got those objects pulled in here. We move along here, we've got a subgrade depth column. And there's a number populated already. What this did is it read the elevation values from those objects, polylines in this case. Now I said you could use feature lines, and in that case it would show varies here, right? Say it's not a constant subgrade depth for a particular region, it actually varies. You could use feature lines to define that. Either way, the elevations you set on those objects, you just set to the actual subgrade depth. Don't worry about true elevation at that location. Just think about relative depth from finish grade. And I can do other things too. I can override this. I can check this and type in a different value. Okay, we'll do that in a little bit. Let's move on now. I've got cut and fill factors. I can specify these per region. And then in the main form here, it's going to show me the cut and the fill, and then the net volumes. And then finally, I have stripping depth in here, and it'll also show me stripping volume. Then the last couple columns are controls on labeling or hatching. And then finally on the right here, we've got a few different other controls on copying an earthwork set. I'll show you some of this other stuff in a bit. We can save out templates. This is creating an AutoCAD table. This is exporting to Excel. Okay. And then if you're defining multiple earthwork sets, the order that you build those in can be controlled by these arrows, such that if you were to run or rerun all earthwork sets at once, it starts from the top down and builds in that order. So all I've done so far is put some layering in for my filter and then specified my proposed and existing surface. I can click run from here. And it's going to take those inputs, calculate my cut and fill, and give me a net per region. Okay. Now we can start to specify stripping depth as well. Let's put a stripping depth of 1 in this area. And notice as I make a change, obviously the volumes would be marked out of date. But if I run this again, we should see a reduction in our cut volume over here. We were at about 2200 before, and now we're looking at about 1533. Okay, so that makes sense with a 1 foot stripping depth. Okay, and we can set different stripping depths for different regions in this way. Okay, so you're probably wondering, well, what's happening here? Like, what's going on behind the scenes? How are you getting these numbers? Let me show you in profile view. Let's show the surface for stripping and the surface for subgrade that we're calculating, because that's important. That's what we're actually after, because then we can use those to calculate our final earthworks. Now, you don't have to have a stripping depth, but you can specify it if you want. Let's close out of this. And I'm going to grab my alignment here. and I'm going to specify a few more surface profiles. I'm going to add the stripping surface and the subgrade surface. And the subgrade, just assigning some styles here. I'll hit OK to this, and now down here in Profile View, we'll see those surfaces show up. Okay, so the blue is the proposed surface up here. The dash blue is the subgrade surface. Okay, so it's generating the subgrade surface based on the depth that you assign to that polyline. The stripping surface is based on those different depths. Okay, and these are just standard Civil 3D surface profiles here. If we want to understand a little more what's happening behind the scenes, let me briefly explain that. Okay. Now I told you we're not doing anything proprietary. There's no kind of special CTC object we're creating. Okay. All we're doing is creating surfaces, adding break lines to them to serve what we're after, which is to get subgrade surfaces and stripping surfaces from which the tool then calculates your earthwork volumes. What Earthwork Processor does is generates a folder with the relevant surfaces. Now the important ones here are the stripping surface and the subgrade surface, okay? And then of course it generates volume surfaces to give you stripping volume as well as your overall earthwork volume as well, okay? So there's a couple linked surfaces in there using some surface pasting and basic break line functionality to generate the numbers as well as the values and calculations that we're after, okay? It drops all of that into a single folder, keeps it real neat and tidy. And all of those surfaces are managed by the tool itself. Now, they're just standard Civil 3D surfaces. You can come in here and you can make changes to them. But if you rerun that earthwork set, it will override those changes. So these are managed by the earthwork set itself. Now, much like some of our other tools, if you never kind of rerun that earthwork set, these are just native Civil 3D objects. Anyone can use them and read them, even if they don't have our tools. So we're just automating the creation of native objects in this way. Let's take a look at some of the dynamicism here. When things change, how does Earthwork Processor respond to this? Let's make a change to proposed surface. I'm going to come down here. I'm going to grab this gutter line right here, and I've used some gutter feature lines in combination with one of our other tools called Autograder to grade out the top and the back of the curb and the gutter line as well. So I'm going to come to the primary feature line here, and we're going to make a few edits. So I'm going to grab this point. It's at 830.82. I'm going to set it to 831.82. And then I can come over to this side. This is at 831.87. We're going to bring that up a whole foot as well. Okay, so a major grading change to the top, the north half of the parking lot. Okay. Now you may have seen a few kind of updates over here. Our profile's getting a little wonky. I'm just going to open up Autograder. This is one of our automatic site grading tools. And in here, I've got a set of a curb grading family. And I'm going to run this so that it updates. You'll see some of it probably in model view here, some of the feature lines updating. And then we're going to see an update on our profile too once we close out here. But if you're not familiar with Autograder, you can use a set of parent feature lines and then define relationships to those to have it generate any number of other feature lines. In this case, it's automatically creating top, back, and flange based on a set of gutter feature lines. So I'm going to save this, close out of here, and if we look down here in profile, might have seen it, it was pretty quick. This updated, this shifted back up, okay? The subgrade surface moved with it, and that's because that subgrade surface is dynamic to the finish grade surface. Now if we run Earthwork Processor again, let's jump back in there. If I refresh this Earthwork set, we should see some updates over here. We've got new volumes. Let's say there's a change to our subgrade depth in this heavy duty pavement area. Instead of 2 feet subgrade depth, it's 1.5. As I'm changing this, obviously things go out of date. Now what happens when I do this? This is an override. If I click run to this, we should certainly see a change down here, and you should have seen that just jump by 1/2 foot, okay? And we also see changes in our numbers. Now when I close out of this, what this actually does, if you remember, the initial numbers come from elevation values assigned to these polylines. This region boundary here, this used to be an elevation of 2. Earthwork Processor set it to 1.5. Okay, so you can control elevations on the objects themselves and then load them into Earthwork Processor, or you can simply specify them in Earthwork Processor. Either way, pretty easy to handle the difference there. Looks like we might just need to rebuild our stripping surface that shows here. Okay, now the same thing with stripping surface. That's dynamic as we'd expect as well. So changes in stripping depth, set that to 1.5 for that first region. I'll click run here. It's going to update all the surfaces and everything. And now we see a deeper area for stripping in this region here. Okay, so I think you get the idea, right? Pretty simple set of inputs: proposed existing surface, some simple polyline, feature line, or survey figure boundaries, and then Earthwork Processor does the rest for you. Now with this information, there's a lot of different things we want to be able to do. You guys probably have a variety of different standards. Do you label this stuff? Do you table it? How do you work with it? We want to give you as many options as possible to export and annotate this information. So let me walk you through some of that. And by the way, before we do that, this name column, you notice it's been pulling the layer names in here. What this is based on is the options we have right in here. I'm going to walk you through a variety of these here. But right down here, region naming, does it take the object layer or the object name? If you're working with polylines, object layer is probably the preferred one. If you're working with feature lines or survey figures more, that naming might be helpful, and it'll automatically populate that right there. Okay, but you can come in here and override these to whatever name you want, because that information can write out to Excel and so forth. Okay. Now a few other options here. We didn't do much with the cut and fill factors, but pretty straightforward, self-explanatory. If we set that, it's taken into account in the cut and fill factors here. But moving back to the options, we have more default options that control behavior for Earthwork Processor, like the default cut and fill factors. If I always want that to be 1.3, it'll do that automatically for me. What are default stripping depths? Okay, what's the table precision? I can have it read the standard drawing unit settings or set it as I like. So depending on what units you work in, metric, imperial, okay, we want to have different controls there. Notice there was a totals column at the bottom. If you have multiple earthwork sets, it will sum all that up for you and you can display that, or if you wish, you can turn that off as well. If we look at the surface creation tab here, okay, I showed you there's a number of simple surfaces in the background being created to make this happen. And behind the scenes, we have real detailed control on those surfaces themselves. Now, most of the time, we don't want to see any of those surfaces, so it'll default to no display. Okay, so here's a default column. And then for each one of your earthwork sets, you can set the style differently, or you can just tell it to match the default. There's also break line settings here. Okay, so those region boundaries, those are being used as break lines to calculate that subgrade surface. Depending on the level of detail on your site, right? If it's a huge site, you probably want to dial down supplementing factors a little bit. You don't need quite that level of detail. Because whether you're doing this stuff manually or you're doing it through Earthwork Processor, a surface with 8 billion points is a lot of information. And if you don't need that data, we can dial that down. Let's take a look at some of the labeling. Okay, the way this works is you have a label column over here, and you can simply check on regions or the entire earthwork set that you want to have labeled. Now, it's just a checkbox there, but what it actually labels is based on settings in your options right here. So if I take a look in this section here, here's all the properties that it's going to label, okay? I can click on this here. Here's the control over which properties will show up in the label. Okay, so maybe I want to see name. I don't need propose an existing surface or layer names. Maybe I don't need stripping depth, okay? Lots of control on that. Let's hit OK here. I'm going to click run, and we're going to see some labels show up in the centroids of our regions. Let's close out of here. We'll take a look at that. Here's that light duty pavement area. What's the subgrade depth, the cut fill, so on and so forth. Okay. If those things don't appear the way you want, let's jump back in there. Let's say, you know, I don't need to show the name of the region. And then subgrade depth, I don't want that big word. So if you double click on any of these properties, you have really detailed control on the formatting. So like I can give it an override name, subcut, for example. And then what kind of precision do we want? We can change this, and so on and so forth. I can even tell it to add units as a prefix, or excuse me, as a suffix. We already had checked on prefix with the field name. So I hit OK to this. Anytime you run earthwork sets, they simply update based on settings and options and the source data it's reading from. Okay, the source data again is existing proposed surface and these region objects. Run that again. We'll see that label update. Okay, we're working on some final formatting tweaks there, like how it displays net volumes and things like that. Okay. So that is labeling. It just places it in the centroid, you know, so depending on the shape of your object, you might move it around like that, but it does all the busy work for you. Notice there's that precision difference. I set this to 2 decimal places, yet the volumes we left at integers. Why don't we move on? What else do we want to do with this? We want to be able to tabulate this. We want to be able to export to Excel. So there's 2 options over here. Create AutoCAD table and export to Excel. And because a lot of these settings tend to be the same from one project or drawing to the next, that's why we put this stuff in options here, okay? It's not something you necessarily want to spell out every time you create an earthwork set, because how you export, what table you create, right, that stuff is often the same from one drawing or project to the next perhaps. You might tweak a few things, but think of these as like AutoCAD options, where all those preferences and things are. That's what this behaves like. If I go to the table and Excel reporting tab, I get a real similar interface where I can first control what shows up in my table. Now in this one, we have to display the name column because that helps with sorting in this way, or keeping different things straight. Because what the tabling will actually do is it'll actually update tables for you as well. You don't have to just create a new one. And then similar information as well. Let's say we want to put on in a title. Okay, it's just a standard text. It'll include a title there. You want to include headers, include units. Do I want totals at the bottom? Okay, all of that you have control over. And then you simply grab your earthwork set. Okay, so we could be doing this with one earthwork set at a time, or multiple earthwork sets if that's how you broke up your site. And then we can come over here, create AutoCAD table. It takes those settings and options. Let's drop this down here. And generates an AutoCAD table for me. So again, nothing proprietary. It's simply an AutoCAD table with styling based on what I set up right in here. Excuse me, right over here. Okay. So your fonts, all that stuff, you can set that how you like. Okay. And it'll report all that information in here. And because I left it on, it shows the totals at the bottom for all information. Because we only had one earthwork set, these totals equal the earthwork set totals up here. Similar with Excel, okay? And currently we have these running off the same set of settings. So a question to you guys, would you want me to separate this? Do we want some settings for tables, some for Excel? Are you doing both and want different results? Yeah, if you have any thoughts, go ahead and put it in the chat or in the questions field. So we'll run an Excel export here. It's going to open that for me, and there's my results in Excel. Again, tweaking some of the formatting, how this stuff comes out. You'll have controls on writing this to perhaps an earthwork template that you work with, not necessarily just an empty one. And similar with AutoCAD tables, if you have a table generated, inserted in your sheet, for example, when you run create table, you'll be able to update a table as well. Those are just some final tweaks on features that we'll be buttoning up this next week or two. One last thing I want to show you guys. Right over here is a save selected earthwork set to an external file, and then load earthwork set from external file. So I can take this definition with my cut and fill factors, my filter settings, and everything else in here that's not totally drawing specific. I can save this out. Okay, put that to my desktop. Okay, and that saves it out to a universal standard JSON file. Those can then be loaded. So you're moving to a different drawing. Okay, these earthwork sets save per drawing. So if you close down your drawing, this will remain in the application. But they're drawing specific. So we wanted to give you a way to, if you created what's kind of a standard earthwork definition, you could easily load that into another drawing for really quick, easy repeat. So I could load an external one here. And in this case, I now have 2 earthwork sets. Okay, maybe you've got 2 different sites. Maybe the complexity of your different subgrade areas, maybe it doesn't make sense to put it all in one earthwork set. You want to do 2 of them, okay? It's very flexible in that way. You don't necessarily have to have 15 subgrade regions for one set, okay? You could have 7 in one, 8 in the other. If there's kind of 2 phases perhaps, and you want to break out those quantities. Okay, a lot of different scenarios there. So we've tried to make it really flexible to handle all those different scenarios in that way. So I think I showed everything I want to show you guys today. The hatching, that's one other thing we haven't quite turned on yet, but it's going to be pretty straightforward. Basically, it'll just hatch region areas like I have done already. It'll do that automatically for you, and you'll have some formatting settings there. So if you're showing that in perhaps an Earthworks plan sheet, it'll do that hatching for you too. So let's follow up with a few other announcements, and then we'll go ahead and address any questions or comments people had. The first one I often get when I do a webcast, and if I forget to mention it, I get this question in emails a lot, is how do I get this? Where is this? Earthwork Processor is releasing in just a couple weeks. Like I said, we're buttoning up final tweaks on this, and it'll be out to you guys very shortly. It will be added to the CIM Project Suite. This is our flagship suite of tools that run on top of Civil 3D. Current license holders, there's no extra payment or anything. Like anything else we add to the CIM Project Suite, including updates to existing tools or new apps in this way, you simply go get the new installer, which you can access from the About menu in any of the tools. Run that installer and it'll update and it'll give you Earthwork Processor. If you don't own CIM Project Suite and you want to get your hands on this, contact your reseller. That would be ATG in the US or SolidCAD in Canada, or simply go to ctcsoftware.com and you can download a free trial of this, of which Earthwork Processor will be a part of within a couple weeks. Also coming up in the same release, we've got a lot of updates to Label Genie. There's going to be dozens and dozens more label scenarios. This is an automatic labeling tool. Included in this is going to be profile and section view labeling. We also got a lot of updates to Autograder. We're going to have additional grading methods that aid with residential housing pad insertion. We're going to have automatic surface boundary creation and a whole slew of other performance and feature enhancements. And then Corridor Mapper, which is a automatic corridor targeting system. It's a tool we've had out for a couple years. We've done a huge overhaul on it. Basically, it's a new tool. It used to be linking layers to subassemblies in a dynamic way. Now you can link styles, you can link by name, you can mirror one subassembly to the next. There's template saving, all kinds of cool stuff. And all this stuff, including Earthwork Processor, it's all free to you guys for anyone who holds a current license, right? So if you don't own it, like I said, go ahead and get a trial. Everything is free for 2 weeks, and then there's a set of tools that are indefinitely free, and then the other tools, including Earthwork Processor, come with a paid license after the fact. They're standalone, network licensing, all kinds of options, all very affordable. I wish you guys a great day and a great week. Stay safe, and we will see you soon.